What's going on YouTube? It is the middle school math man. This video is going to be on exponent laws. So we're going to run through all 7 of the exponent laws, and we're just going to go one by one. So the first one is called product of powers. So this is going to deal with multiplication. So when we are multiplying exponents that have the same base, we are going to add the exponents. So when we multiply, we add the exponents. So if you look at number 1, keeping the same base, 8 plus 2 is 10. Looking at number 2, base is the same, so keep the same base. 9 plus 3 is 12. Now number 3 is a bit different because we have a 4 instead of a variable, but it's still the same base, so keep the same base and add the variables. Well, that's not fully simplified because we can do 4 to the 4th power. So your final answer for that one would be 256. Now, if you look at the second example up here, this is just kind of a confusing way to say if we have coefficients and then the variables are the same base, we're going to multiply the coefficients, which they have, x, y up there. So 4 times 2 is 8, and then same base, so we're going to add the exponents. So that would be 8b to the 7th power, and then number 5 is going to be 6y to the 7th power. So whenever we multiply the same base, we add the exponents. Moving on to quotient, so this is division, and any time we have division, when we had multiplication, we added the exponents. Division is basically the opposite. When we're dividing, we're going to subtract the exponents. So b to the 8th divided by b cubed is b to the 5th power. Now anytime, we're going to come across this a lot, anytime you have a variable or you have a number, it is always raised to the 1st power. So keep that in mind. So number 2 is going to be z to the 4th power. Now 3, 4, and 5, they have those coefficients. So as you can see in the examples up top, we're going to actually divide the coefficients. 4 divided by 2 is 2. So that's going to be 2b to the 5th power. Number 4 is going to be 2y squared. Number 5 is going to be 5x squared. So when we divide, we have the same base. We are going to subtract the exponents. Moving on, now we're going to talk about anything to the 0 power. So if you take a look at the 3 examples, n to the 0 power is 1. Anything to the 0 power, any positive number is just 1. But also, if it is a negative number, and that's in parentheses, raised to the 0 power, that's also going to be 1. If it is a negative number, not in parentheses, that's going to be negative 1. So that's just something we need to keep an eye out for. So negative 5 to the 0 power, there's no parentheses, so that's going to be negative 1. Number 2, we do have parentheses, so that's going to be positive 1. Now number 3, let's look at this piece by piece. So negative 2 to the 0 power, without parentheses, is negative 1. And then we have plus. Negative 2 in parentheses to the 0 power is 1. So your final answer for that one would be 0. Negative 1 plus 1 is 0. So we just need to keep in mind these 3 different examples we could have as we're dealing with 0 property of exponents. Now we're going to move on to power of a power. So this is going to be, as you can see in the examples below, this is going to be something raised to a power, and then on the outside of the parentheses, it's also going to be raised to a power. So this is a great example right here. X squared, in parentheses, raised to the 3rd power. Anytime we have a power to a power, we're not going to add the exponents like we did with multiplication. We are going to multiply. So b to the 5th power squared, that is a power to a power, So an exponent to an exponent, that's going to be b to the 10th power. Look at number 2. That's y squared raised to the 3rd power, so that's going to be y to the 6th power. And then number 3, that's going to be m to the 20th power. 10 times 2 is 20. So anytime we have something that is raised to an exponent and then raised to another exponent, that is called power of a power. So we're going to multiply the exponents. This next one is called power of a product. So it's kind of similar to the one we just did, power of a power, but now we're going to throw some coefficients in there as well. So if you take a look at the examples, the exponent that's outside the parentheses, just like if you were distributing normally, the exponent outside the parentheses is going to go to everything inside the parentheses. So let's just take a look at these different examples. I think it's going to be a little more clear. So this cubed is going to apply to the 3, and it's going to apply to the y squared. Try to draw an arrow there. So if you have, I'm actually going to kind of break this up. This is 3 cubed, and then y squared raised to the 3rd power is what we just talked about, power of a power. So that's going to be 3 squared times y to the 6th power, and 3 cubed is 27 y to the 6th power. So number 2, this squared applies to everything. We have 3 things. We have a 6, we have an x, and we have a y. So 6 squared times x squared times y squared, that's going to be 36 x squared y squared. That's going to be your final answer. Can't simplify that anymore. And again with number 3, I'm going to write it up top here, 3 cubed x squared raised to the 3rd power. We multiply, so that's x to the 6th power, and then y to the 6th power. So your final answer is going to be 27 x to the 6th power, y to the 6th power. So similar to power of a power, anytime you have an exponent outside, it's going to apply to everything on the inside. So with power of a power, we just had one thing inside the parentheses. This is adding on to it. Now we have some coefficients, or we have multiple variables inside the parentheses. Next one is power of a quotient. So this is very similar to what we just did, except now we have division. But keep in mind that the exponent outside the parentheses applies to everything. So number 1, we have b squared divided by c squared. It applies to both of those. Now we can't subtract those because they're different bases. So that's going to be your final answer. Number 2, remember this 2 applies to the 3 and the b. So that's 3 squared, which is 9. So 9b squared. That is not very good handwriting. 9b squared divided by c squared. And b and c are different bases, so we can't divide those. We're just going to leave it how it is. Now if we look at number 3, 3 squared is 9. B squared raised to the 2nd power, we multiply. And just remember that it applies to both the numerator and the denominator. Moving on to the last one is negative exponents. So one way you can think about this is if you're negative, you're unhappy. So change floors and you become positive. If you're negative, you're unhappy. So change floors. So change what side or what the top or the bottom, the numerator or the denominator. You're going to change what part of the fraction you're on, and you're going to become positive. So that's just a kind of a silly way to think about it. So if you look at the examples up top, let's see how we can apply those to our practice examples. We can't have negative exponents, so b to the negative 8th power, well, this is just like this example here. So b to the negative 8th power is b to the negative 8th power over 1. Anything over 1 is itself. And now you're unhappy with where you are right now. If you're negative, you're unhappy. So change floors, change the side of the fraction you're on, and you become positive. So basically, anytime you have a negative exponent, if it's in the numerator, you're just going to move it to the denominator. If it's in the denominator, you're going to move it to the numerator. So in number 2, we're just going to move it to the top. So we're going to have z cubed over 1, which is just z cubed. Now there was one thing I didn't talk about. Remember, if the exponent is positive, don't kick it around. So what it means by that is, if we have an example like we have in number 3, well, the x squared is already positive, so we're not going to move it because it's not negative. We don't have to do that. We only have to move the exponent if it's negative because we can't have negative exponents. So all we're going to do here is we're going to move the y to the negative 4th power to the numerator. So that's just going to be your final answer. X squared times y to the 4th power over 1 is just that. For number 4, both of them are negative, so they're both going to switch. So we're going to have c to the 4th power over b cubed. That's going to be our final answer. They were both unhappy with where they were, so they went to the other side of the fraction, and now they became positive. In number 5, the c to the 5th power is positive. So remember, don't kick it around or whatever you want to say. So we're going to move the b to the negative 5th power to the denominator, so your final answer is going to be 1 over b to the 5th power times c to the 5th power. So that was all 7 exponent rules in one video. So a lot of material. But if you're just taking it, step by step, it's not too bad. Just remember, some of these were similar. Power of a power, power of a product, power of a quotient. Those were all very similar. You just got to make sure you distribute the exponent to everything inside. And then just remember those different rules. When you multiply, you add. When you divide, you subtract. Remember those couple of zeros. And then negative exponents. If it's negative, you move to the numerator or the denominator. Depends on where you start.